Welcome to Spring LIB.
All right, so in this question, we're given some information about the time it takes for some toddlers to learn, or some young children to learn how to ride a two-wheel bike. Probably not toddlers. Part A asks, I don't know what that is there. Part A asks us to identify on part one, what is the mean amount of time it takes to learn to ride a two-wheel bike? And we are given that it's 6 months. And then part two says, what is the sample standard deviation? And we are given that it's 3 months. What is our sample size? And this is based on 14 children. And what is n minus 1? And literally that's 14 minus 1, so 13. So part B then wants us to define in words what random variable x is, capital letter X. And what is the random numerical variable here? What is randomly changing? And that is the number of months it takes. So some kids are going to be able to figure out how to ride the bike quickly, and other kids it's going to take them a lot longer. So the number of months it takes to learn to ride a two-wheel bike. To learn to ride a two-wheel bike. All right, part C then says, okay, well, what is the mean of this random variable? And it's literally the mean of the number of months to learn to ride the same two-wheel bike. But from our sample of 14 kids. Okay, so there's two big distinctions. This is more population, the number of months it takes to ride, and then this is sample. All right, so part D asks us then, what distribution should we use? And we are going to have to use the t distribution. And the reason we have to use the t distribution is because sigma, which is the population standard deviation, is unknown. All right. So moving on to part E, we're going to construct a 99% confidence interval. So we need to look at a couple pieces of information. So the structure for finding a confidence interval is going to be our sample mean plus or minus our z-score for whatever our significance level is. So I call it the z-star value because it's not really a z-score specific to any specific data value, but the z-star value that's associated with the 99% confidence interval times the standard error. And in this case, the standard error is the standard deviation divided by the square root of n, since we're dealing with means. So this will give us our confidence interval. So we need to identify what this z star value is. So z of 99% means I have 0.01% or 0.1% rather. So 0.01 on either side, and I'm going to divide that by 2. So I want to know the z score that would be associated with something that is marking off the top 0.5% and the bottom 0.5% of the distribution, and that comes out to be about 3.01. So then I can substitute the values that I know. I know that it's 6 months plus or minus my z value of 3.01 times 3 over the square root of 14. So that's going to give us our confidence interval, which is 3.58 to 8.42. So we can be 99% confident that the average amount of time it's going to take or the amount of time it's going to take to learn to ride a two-wheel bike is between 3.58 months and 8.42 months. Okay, so then it asks us to go on to construct the normal model for that. So this is what our sampling distribution for that would look like. So we're not looking at the distribution of the original 14 pieces of data, but if we looked at a whole bunch of samples of 14, what would we expect the center of that to be? And we would expect the average of all of the possible samples that we could take to be right around 6, and to span 3 standard deviations in each direction. And I know this because our sampling distribution should follow a normal model. So this is our sampling distribution, and the scale is measured here in months. So I need to know what just this piece right here, the standard error, is. And if I take 3 divided by 0.14, that comes out to be about 0.8 months. So when I construct, or when I label my scale on the normal model here, this would be 6.8, and then 7.6, going up and 8.4, and then going down 0.8 each time. This would be 5.2, 4.4, and then 3.6. So that is my normal distribution. And you can see that if we're going 3 standard deviations above and below, here's our confidence interval. 3.58, that's a little bit below, and 8.42 is a little bit above. So this right here is our 99% confidence interval. So what is then what it's called the error bound, also known as the margin of error. And the margin of error is this piece of the formula. So this 3.01 times the standard error. So we're given that it's going to be it's about 2.42. So this span from the center of the graph up is 2.42. And that amount is also going down. Okay, so 6 months, give or take 2.42 months. That's called the error bound, or margin of error. And I think if you multiply by 2, you'll see that it's 4.84 months from the beginning of the confidence interval to the end. So just labeling the parts of the answer here. All right, so then the next question says, what if we switch gears and we look, instead of a 99% confidence interval, we look at a 90% confidence interval? And what would change about this formula? And the only thing that would change would be the z star value. So instead of looking at 0.01 divided by 2, I'd be looking at 0.1 divided by 2. So I'd be looking for the z-score that marks off the top 5%, or 0.05 of the top 5% of the data, or the bottom 5% of the data. So that gives me then a z-score of 1.64. So instead of 3.01, I'd be dealing with a z-score of 1.64 that's marking off my boundaries. So that would be a much narrower margin of error, because I'm only going to go out 1.5. So instead of going out quite so far, I'm going to go 1 and a little bit more than a half. So I'd be looking at something that's a little bit more like this. This would be my 90% confidence interval in here. So how would it change? It would decrease the interval. How would the error bound change? Well, then it would also decrease that. So if we looked at 1.64 times the standard error, which was 0.8, that gives us 1.31. So and I'm going to go up 1.31 months and down 1.3 months. So if I multiply that by 2.62 about, then the total span of that confidence interval would be 2.62 months.